Hey guys, this is a tutorial to show you how to simulate a simple pendulum and a double pendulum. So first you have downloaded three files like here, which is Dynamics 2, Dynamics and Tutorial Pendulum. Please save that in a workspace that you know. For example, I know these three files are at this position, so it's important that you know where you store these files. Then you open Matlab. I assume that you have some background knowledge in Matlab, so I won't be doing some detail on the interface. It's important to be in the workspace where you save the files. So for example, here is Home, Nick, Documents, W, Matlab and Pendulum. And you open this workspace and we can work on the files. The files we will be mainly working is called Tutorial Pendulum, and we will be running each of these parts one at a time. Right? So in the first part we're gonna plot a line, which seems quite simple. It must change according to the parameters L, which is the length of the line, and alpha, let us begin just with the line. To run each of these parts of the code, you have to use Ctrl and Enter key, intro. So we have plotted a line which has from x0 to x3 and from y0 to y4. Well, that's simple enough. Now we have a little more complicated here, where we want to plot a line according to an angle theta, or in this case th. The angle we will be plotting is 53.13, but we have to put that in radian. Therefore this pi divided by 180. The line will have a length of 5. So let's see. Okay, now we have x1. X is a vector. Oops. X is a vector that has two components, where 0 corresponds to this point here in the origin, and 4 corresponds to x in this second point here. And the same is true for y. The next part, we want to move that line from an angle of 0 to an angle of 53.13. So in this case, we'll be making a vector using the command linspace, which is a linear space from 0 to 53.15 degrees. Now this 100 represents how many angles in between do you want to have. So this vector th has a size of, we have to run this first. So we want to do this. Well, it is moving. That's good enough. Alright. And the angle has a size of 1 to 100. That's fair enough. So it does what it's supposed to do. And the initial, or the origin, is again 0, 0. So with this for loop, we'll be going from each of the elements of this vector th, from the first position of the vector to the last position of the vector, and rewriting the second point of the line. We'll be plotting this. We will be putting a grid on, and we use pause in order to see what Matlab is doing. If we do not put this, we won't see anything until the last part of the simulation. So pause is important here. But we have seen in the simulation that this axis move, and we cannot see very well how the line is moving, and it seems like the length is also changing, so it's quite not good. So with some aesthetics, we will fix the axis in the part 4, and we'll be doing so with this common axis. So everything is the same, but this common axis. We'll be putting the x minimum, so the minimum x, the maximum x, the minimum y, and the maximum y. And the result is like this. We'll be moving from 0 to an angle of 53.13. Now that's better. And we know that now we can see that this length is fixed, etc. We can improve this a little bit with some aesthetics. For example, we can put a point at the end of the length of the line, and this represents better what a pendulum looks like. This point at the end of the line we will be using this command. So this first plot will plot a black line, while this plot will be plotting a black point at the end. So this is the point at the end, and we'll be increasing the size of the marker, in this case the point, by a font of 32. Then we'll be using hold on and hold off to to hold the line, and then plotting the point. If we don't use hold on, then it will plot the line, and then will erase the line, and then it will plot the point. So that's not what we want. Now that we have achieved this marker, we can put some dynamics there.